So I'm going to walk you through this code. And again, like I showed you last week, you don't need to be a programmer to use SAS. You can use the task. In fact, all this code you see here that I'm going to show you was all generated by using the task. I didn't have to think about the code. I just followed all the points and click. So the first thing here is that I've given you guys this data set, which you would find here. So once you go to the shared folder that I gave you, so in there you now have the Glassdoor data.csv, which you can all explore. All right, so the first thing here I'm doing is I'm trying to read this data. So I'm running this to read the data. And when you're working on projects, I always tell people don't create a spaghetti kind of code where everything is in one file. Break everything down to divide and conquer. So in an ideal code, this will be one SAS file, which I'll call read data. Then I'll have another file for other activities, so it's easy to manage. So I can look at the pro content just to see what variables are in the data that I just read. And so in here, I can see I have age, bonus, and so on and so forth. So I can pick into the content of the variables, and I can see the data type, numerical, categorical, and so on. So that's what that's what this line of code does. So next, I talked about summary, looking at exploring the data by creating a summary statistics. So what I did here to create a summary statistics for the continuous variable, I simply wanted to plot the mean, the minimum, maximum, and the quartiles. So I would run this set of codes. And so this gives us that table you saw in my notes where you have the mean, minimum, and so on. And again, I want to look at explore the categorical variables. So I create a frequency table, and that's what this line of code does. And that gave me all this frequency table, which I had in the slide. Once more again, to do all that, you can simply just come here to statistics, and then you have one-way frequency. That's what I used, and that would give you this code as well. Now I wanted to create a new variable, so I said I added income plus bonus. So my initial variable is Glassdoor. Now I'm creating a new variable, and I'm calling it Glassdoor1. Okay, and in that new variable, I'm adding a new. In that new data set, I'm adding a new variable called total pay. Because right now, if you look at your libraries, you only have Glassdoor, right? And Glassdoor has a total of 9 variables, 9 columns. Okay, now let's go back here and run this. So now we have 10 columns, as you can see. And now under library here, under work, you have a new data set called Glassdoor1, which now has the new variable that we just created called total pay. I hope this is slow enough. Cool. All right. And now the next thing is I want to plot the histogram for income, bonus, total pay. If I do not know much about this code, you simply come here and you have histogram. That's the task you're going to use, and then you can specify the variables. So I'm running this, and that gives us the histograms, as we saw in the notes. And what else do I want to do? I want to create the box plots. How do I create box plots? You have box plots here. So simply use this task, and that will generate this code for you. So I'm just going to run all of this at once. Gender and age. And so we have this for gender, the box plot, and the other scatter plot for age. So this is a scatter plot, this is a box plot, and how do you see that? You can see V box, that's box plot, scatter, that's a scatter plot, because year, age, and total pay are continuous variables, and so that's a scatter plot. But in this case, total pay is continuous, but gender is categorical, and that generates a box plot. So for a box plot, one of the variables must be continuous and the other categorical. So now I decided that I wanted to create this dummy variable. So I talked about the dummy variables earlier, whereby I'm creating a variable called female, and when it's set to 1, it's female, otherwise it's male. Now, and I'm going to create this variable and store it in under Glassdoor. So what I did here is this, you won't find the option here. So this is me coding this myself. So I'm using the data method, and I'm creating a new data set called Glassdoor2, and I'm calling the other data set we have, Glassdoor1, that already has total pay. And now my new data set is that if gender is equals to female, then female is equals to 1, else female is equals to 0. So meaning that if gender is equals to male, set that value to 0. So this will create a binary variable for me, or an indicator variable. So now we have 11 columns, and if we move all the way down, we now see female 1 0 1 0 0, and if you look at gender, that is female male female male male. So that would be 1 0 1 0 0 0, and so on. So basically, what we are trying to do at the end of the day is that we want to come up with our analytical data sets that we would use when we are performing regression. So usually you need to create your data set to be to what you're going to use for your regression analysis. Usually the initial data set that you have or you wrangle is not what you're going to use directly for regression, but you have to format your data set to meet with what you are trying to examine in your hypothesis. This is a scatter plot of total pay and female. So that the one that gave us male and female, or yeah, male and female. Then I decided to create a model where we have female as a predictor and total pay. And when you run this, you have this output. And so this is the table that we're trying to interpret in the slides. Now, what about creating the dummy variables for education? How did I go about it? So this is how I created it. Now, here again, I am making use of the previous data set, which is Glassdoor2, but I'm now creating a new data set called Glassdoor3. And I'm not setting it into a library, meaning that once I go off this session, the data set goes away. I usually, when you're doing your dissertation, I always encourage people to create a library so that you don't have to keep generating this data set on every time, but you already have your final data set in your library, and you only call the library with your data. But anyways, what did I do here? So I set college to equals 0, and so if college is equals to college, then college is equals to 1. So that means first I'm creating a variable called college, and I'm making everything 0. But now if education is equals to college, now set college to equals to 1. So that will give us 0 and 1, and wherever there's 1 in this new variable, it is college. The same thing with masters, and the same thing with PhD. Now you notice I didn't create for high school because I'm using high school to be the reference variable, basically. So if you run this, now as you can see here, we now have the college variable, we have the masters, and we have the PhD. So these are dummy variables. Now with modern statistical software, we don't necessarily have to create these variables because we can just use the education variable on its own and set whichever reference variable we want. without having to create these dummy variables. But assuming that we did, now I can now create a model where I have total pay with and I'm regressing with college, master's, and PhD. And when I run that, so that gives me this output. We have the intercept. We know that we're controlling for high school, basically here. However, like I said, we could just run a regression model and set the reference variable we want. So let's say I want my reference variable to be college, and I don't want to create all these individual variables. So I'm just regressing total pay with education. We can do the same thing. We can make the reference variable high school. We can make the reference variable PhD, whichever one you want, and simply use the variable education. And the software will automatically now create all the reference variables. So we can see education for high school, education master's, education PhD, while college is the reference variable. And so you can come in here and say, okay, I want this to be I want my reference variable to be high school, for example, and then you can change this to high school. Or I want my reference variable to be PhD. You can change this to PhD. And then you can run this, and our PhD becomes the reference variable. So PhD now becomes the reference variable, and we now have this different output and the estimates. All right, one more thing. Now we can combine all our predictor variables. So we have female, college, master's, PhD, age, or we can simply just have education and age, and then reference for, you can simply just have female, education, age, and then our reference variable would have been PhD. And we can run this without the picture. So I'll run this one. Next, we'll talk about the Modal Diagnostics. And so we have this. And so here we have our model, and we can see the p-value, and we can interpret it accordingly. All right, but I hope this was helpful. This is the SAS code and how to show all that I've done so far in the 2 slides.